thank you all for showing the interest with the topic and also making the time to join here in our web series. You will see several parts of it, points within the webinar. We will also point to the future sessions that we will be going on. We have split the seminar or the webinar into three parts. So the first part I would like to cover about the mobility transformation itself, what has triggered, and then introduce electric vehicles in relation to what we have known, combustion engine, and maybe also look a little bit into the EV situation in India. And then I would like to lead into the next session, which is from Vijay, about the safety, and then the third session from Mr. Money, from the buyers and the consumers perspective. First of all, Vanakkam, Guten Tag, hello, the three languages that I know of. I would like to welcome you all very shortly. A very quick introduction about myself. My name is Henry Joshua. I come from Chennai, but I've been living outside India for more than almost 30 plus years. In different places, I've studied and worked mostly in the US for about 10 years at General Motors, another year or so in Stellantis, a few Fiat Chrysler back then. And then now I live in Germany since 2014, and I've run different roles. And currently I'm responsible for the global advanced service area within AVL. This is my LinkedIn. So if you have any questions, or if you'd like to connect beyond the session, you're more than welcome to do so. But let's get into the topic right away. What triggered the transformation? I think that's a very interesting question, right? We all know EV is a hot topic in India, but before it was a hot topic in India, it's been a hot topic even outside in other places. But what was the start of it? In around 2017, there were 5 mega trends that was identified: rapid urbanizations, climate change, global economic power shift from the west to the east, demographic and social change, meaning there are countries like Japan or China, which is getting a lot older, also in Germany. But in India, the demographics, the people are getting younger. The average age in Germany is 47, whereas the average age in India's population is 23 or 25, I believe. And then there are technological breakthroughs. In the first glance, these topics might look a little disconnected from mobility, except for climate change. You know, that's something we all can jump on it right away. However, you will see that these topics are direct influencers of a mobility disruption. Rapid urbanization, what happens? I mean, you know, migrations from other cities, people come to Chennai. What happens? Congestion. How do you deal with congestion? When congestion happens, there's pollution. How do you deal with the pollution, right? What about the energy demands? So these points are all connected. When we speak of cars getting more intelligent, then the technological breakthroughs like IoT, AIs, MLs, they're all somehow tied into this. And the climate change is an easy one to point to, right? But the expectation of people, the willingness to share with topics like Uber or Ola, you know, people are a lot more open for sharing. I mean, maybe 10, 20 years ago, you would have gotten instruction from your parents: don't talk to a stranger, don't get onto a scooter with a stranger. But now we actually get into a vehicle with strangers, right? So the things have changed. What these have led into, specific for mobility, is something called CASE. The mobility has been disrupted in 4 pillars or 4 areas: connected, autonomous, shared mobility, and electrified mobility. I mean, we will focus a little bit more on the electrified mobility today and in the coming areas. A quick glance on the EV situation in India. I mean, there's a lot of numbers and tables. All that you want to take away from this slide is India is planning to achieve 30% of its sales of any new cars, any new vehicles that's being sold, 30% to be EV by 2030. Now, this is actually from a World Bank report, which was released only a few days ago. There are a lot more details, and I've given a longer post in LinkedIn, but this is, think about it. I mean, it's huge, right? India's transportation is projected to grow 2.7 times within the next by 2050, I believe. And on the other hand, almost half of the top 50 polluted cities in the world are in India. On top of it, to add fuel to fire, India, we import 82% of fossil fuel oil from outside. So the political factors, the economical factors, the ecological factors, these are all pointing towards a need and a rush for India to move more towards electrification. When we speak of electrification, electric vehicles, yeah, what is it? There is a part of it that we do know quite familiar with, which is the combustion engine, meaning anything that burns in the car and gives you the power. Petrol, diesel, ethanol, there's n number of fuels that can do the same job. And when we speak of EV, there's something that we want to be clear. It's not just battery vehicles, right? Let's call it XEV. The X can be replaced with H as a hybrid, as a plug-in hybrid, as a battery, or even fuel cell, or what we call as the FCEV, right? Let's focus on, I mean, leave the fuel cell out for now. We will get back to it shortly, but let's have a quick basic comparison, because this webinar today is intended to give you a very general introduction and an overview of EV and powertrain. The deep dives will follow. Yeah, I mean, I think we will also organize some technical discussions and technical trainings. But for today, from a very simple overview, general point of view, let's take a look at what we call as the conventional vehicle is very simple. Pretty much we burn things. There's a fuel you would be able to inject, and then there is an injection system. We burn the fuel is converted to heat, and heat to mechanical force or energy, right? Now, if we look at electrification, the HEV and PHEV are viewed more as bridging technology, but not so ideal. I mean, a buyer could think, oh, okay, what about the battery charge if it runs down and gets empty like my phone, and therefore I will go for an hybrid. But actually, from both an economical point of view, manufacturing cost, and ecological point of view, hybrids and plug-in hybrids don't make much sense, but they calm down the anxiety. You know, in both of these cases, the difference between hybrid and plug-in hybrid is simply as you see in the title. The battery electric vehicle, there, the motion, the actuator is simply the motor. In hybrids, you have the actuator as the combustion engine primarily. I mean, maybe up to 0 to 50 kilometers or the city driving, you may use the electric motor, or you may use the electric motor only to charge the battery, but they are not, how much of range is being provided by the motor or the battery in a hybrid vehicle. That's something to be questioned, right? Another step to look at it is, let's look at the fuels. What's the consumption? Here it's petrol or gasoline, same thing, hybrid, plug-in. There's fuel and electricity, and here it's only electricity. So you look at the actuators as well here. Advantages, I'm not going to read through everything, but then a primary advantage, what we put forward for a battery electric vehicle is usually the environmental part. But to be honest, I don't think it's a complete solution. For electric vehicle, the natural thing is you have to question where the energy is generated from. You know, the well to wheel. It's not just the wheel, the tank to wheel part. It's not just what's happening at the car. An electric vehicle is a discussion about the entire ecosystem. If it's not environmental, is it any beneficial? Yes, actually, electric cars do provide a much greener option compared to the conventional vehicle, especially if you calculate the life cycle, the entire life cycle of the car. The break even typically happens around, in terms of emissions, happens typically around 3 to 5 years. Yeah, and same for the ownership, the cost. You'll see this as well. So, but primarily, I also believe that the driving impetus is political, oil independent. So I think there's a political and economic force also behind the EV story here. And yes, any benefit I take, it doesn't have to be 100% green, but any benefit that a battery electric vehicle can provide, I will take it because that's the times that we are in, right? Um, Fuel cell, only a very quick view. The way it happens is the fuel is, of course, hydrogen. Hydrogen is pumped into the tank, and then we have something called a PEM system, or there are different systems that's the fuel cell is going to convert the hydrogen to electricity, and that electricity is going to be used for charging your battery, and then which in turn drives the motor. So that's how the fuel cell works. But let's look at a little bit overview. If I ask the question, have you been driving an electric car even with the petrol or gasoline? Actually, yes. There is something called the level of hybridization or the degree of electrification, right? Yes, you have been driving the car with the battery to drive the 12-volt battery or the 48-volt system. But the point is, how much of range do you get this from the battery? None, right? Yes, we can have an engine start, stop. The alternator is going to work, but doesn't mean you have a range. So yeah, so I think that part from therefore it's called the micro electrification. Then comes the mild, where you have the belt starter alternator. And then if you look at, then comes the hybrids, what we have looked at, and then comes the full BEV. You look at the difference, the range makes a difference, and also the size of the battery and the power, right? Now, actually, we have vehicles already with 400 to 800 volts. Porsche Taycan is an example with 800 volts, but most cars you will find as a 400 volt system. What's interesting is we do have right now the technology is going over 1,000 volts. Imagine that you're going to be sitting on a car over 1,000 volts. Then comes the question of safety and design and the appreciation for the engineering. That doesn't mean it's dangerous. Let me put it this way. No, it's actually a lot more optimized. With maybe in the future, when we have a little bit more technical webinars, we will go into the discussions of why what's the difference when the voltage is higher or lower? Why can't we have a lower voltage and a higher amperage car? So there are certain optimizations, but we will look at it in the future. So for now, the main key information here is there are degrees of electrification, and the EV cars are going to have a different size of your battery and power. Cost. This is another point. I think when we buy cars in India, we ask for a few things, right? What's my resale value, or what's the overall maintenance cost? What you will see here is the overall total maintenance cost for an EV is about 40% less than a conventional car. Why? Very simple, because there's a lot more reduced parts. There's around 2,000 parts in an engine, but then there's around 200 parts in a electric motor. Also, there are parts like air filters, fuel filters. There is none. You don't need it. There is nothing called spark plugs in an EV. So simply you don't need a number of parts. But what's interesting, which might be intriguing for you, is brakes, suspensions. These are common parts. How come the cost of a brake is less in an electric vehicle compared to a combustion car? Do you brake less? What's the difference? Fine. I mean, spark plugs are not there, understood. You don't have to ignite anything. But why the brakes are less? The brake cost is also less because there's something called regenerative braking, right? And also because of the way the inverter is, let's call it the controller for now, the way how the controller or the vehicle controller is optimized. So based on this, even the wear and tear on the brakes are less compared to the combustion engine area. Let's take a deep dive into just the battery electric vehicle. Now, in this case, what are the main parts of a BEV, an electric vehicle, what we call as the battery electric vehicle? Well, there are primary parts are e-motor and inverter. Together, they are also called e-drive. Then there's your battery, the key area, and then there's an onboard charger and also a DC-DC converter for, when I say we have a car working at 400 volts, we also have parts that needs to work at 12 volts, right? I mean, your dashboard, LEDs and chargers and like this. So you have to step down. So those are DC-DC converters as well. And of course, an external quick charging unit. There's a term we use called powertrain, the core part of the vehicle. In that case, it's quite simple. We have only three things: a battery, inverter, and an e-motor. So that's pretty much what we want to do. Let's take a quick roll. Battery is an energy storage device, and the language that the battery speaks is a DC current. The language that a motor speaks is an AC current. What does inverter do? This guy, the primary function is somehow to translate the DC to AC and AC to DC backwards, right? So when we brake, the motor becomes a generator. That's the regenerative braking. Or when you coast down on a hill or so, and then that's charging back the battery. Inverters, that's the basic function of an inverter. However, I would say inverter is the most intelligent part between these three powertrains. Inverter makes the decision. People say, yeah, battery has something called a BMS. BMS is a dumb smart system. Most of the decisions and things, BMS can monitor, but it cannot control, right? The inverter is more of a comparable part for a controller. Battery, when we say battery is the key part, why is a key part? Why is it so important? Why does everyone speak about battery in a battery electric vehicle? Well, battery is the most expensive component of a BEV. It makes up for around 25% of the car's cost, only the battery. Now, if we look at the powertrain, meaning between the battery, inverter, and e-motor, the battery alone is more than 59%. But to have no fear, the price of the battery has been going down. In the last 10 years, it's about 89% has gone down. So it's also projected that we will achieve $1.100 per kilowatt hour from 900, right? So we will achieve or go below $100 per kilowatt hour by between 2023 to 26. I mean, right now, because of certain political situations and the change in demands and raw material supply, these are changing. The projected time is moving plus or minus. What used to be 2023 now somehow have moved between 2023 to 2026. We spoke about the battery pack. So battery pack, so here what we look at is the battery pack. Battery pack is nothing but a collection of battery cells. So a collection of battery cells become a module, and the collection of modules becomes a pack. Think of your remote control cars that you may have, or even a TV remote control. A single cell is a single cell, but when you put them together in a series or parallel, when you use 2 or 3 or 4 cells, they are technically becoming a pack. Now, as an individual cell, it's also interesting to see how the cost is broken down. So the cathode material, we will look at what are the parts. The cathode material, this is what you hear quite a lot, which is contributing to about 51% of the cost. And the key contributors to these costs are what we call as rare earth materials. nickel, cobalt, manganese. Of course, there are different chemistries that's being developed where we may not even need nickel. So when we say a battery are every battery in all the EV cars are not the same. The chemistry is different, um, and the compositions are different, and therefore the cost, lifetime, aging factors, these are all different. Again, I'm throwing a few terminologies, but we will deep dive into all of those in the future webinar series. So yeah, the cathode contributes to the larger part of the cost. Then there's the anode, separator, and electrolyte, and the manufacturing process itself. What are these anodes, electrolyte, cathode? Let's get introduced to the battery cell. There are two electrodes, cathode and anode, and then there's a separator who tries to keep those two parts separated. And then in between the blue area, what you see is actually the electrolyte part. And then, of course, there's a battery housing, right? How does this work? Inside the battery, what a battery does, unlike it converts a chemical energy or a chemical reaction into an electric reaction. How does it work? Very simple. Think of inside the battery, there are these lithium ions, which are positive, and also along with the electrons. Think of them as your teenage boy and a girl. They are always wanting to be together. However, the separator is like your parent, right? They say, well, only one of you can go through. You can't be together. However, the electron finds a different way to travel and try to get to the lithium ions. The lithium ion, for example, when we discharge, is moving from anode to cathode, and when we are charging, it's going from cathode to anodes. Whenever the lithium ion wants to move, only the lithium positive ions are allowed to go through the separator, and therefore the electrons must travel outside through the other circuit. And that's how we get electricity, right? And inside there's something called intercalation. This is nothing but think of the wool clothes, the sweaters getting stuck on a Velcro or so. That's how it is. So these lithium ions are traveling back and forth, but then they have to get stuck into certain materials. This is the cathode and the anode materials, and this is what we call as intercalation. They have to stick to it and stay there. And that's how pretty much it works. So when we discharge a battery, the lithium ion moves from anode to cathode, and the corresponding electrons go outside. And same way, when we charge, it goes the opposite direction. So in this entire story, there's one thing that we do not want. We do not want the two electrodes getting in touch with each other at any point of time. This is a bad news. This is what causes thermal runaway, or in simple terms, the famous fire, right? These famous fires can actually happen in many different reasons, meaning there are many different reasons that can cause the separator to break. When you crash, that's a mechanical reason. When something penetrates, like a nail, that's a mechanical reason. Then there are also electrical reasons, bad charging habits, or overcurrents, under voltage. Those are all different reasons things can go. And of course, heating, right? Overheat, underheat. Just like our human body, there is an optimal temperature. The battery is also happy to function. And coincidentally, it's actually also room temperature. So any extreme cold or extreme heat is not actually optimal for the battery. So the battery can actually catch fire from three basic reasons: mechanical abuse, electrical abuse, and thermal abuse. What means these abuse is charging, actually a normal charge and abuse. All of these, I think we will see in the next or the future webinars, but for now, there are three major reasons that can actually cause this thermal runaway. Why do we call it a thermal runaway and not a fire? Because it happens quite fast. Actually, the thermal runaway happens quite fast. This picture seems to be quite confusing. What I wanted to show here is, even if there are abuse, meaning something is going wrong, a crash or so. There is a certain point up to which it's recoverable, meaning we can not. It's not a big deal, you know. Just because you overcharge one time doesn't mean something is happening. There are certain conditions. However, when beyond a certain point, it's recoverable, and beyond a point at the 8-second level, there, the burning happens really fast. The battery does provide a certain warnings before then. There are gases released, the battery swells a little bit, but beyond a point, the flash, the runaway happens, and there's no way we can control that after that point. Before then, there are certain actions happen. What's interesting for you to see is the amount of temperature that's being generated, or what happens at that point. It's huge, right? What I show here is called a tomography. The video starts at this point, not here, but I marked where the video starts, and it goes through. And once it reached the 8-second point of this video, how quickly the battery burns is quite, I wouldn't call it impressive. It's actually quite crazy. Let's put it this way. Yeah. So what you do, does it mean the battery is bad? No, that's exactly where testing comes in. And any manufacturer, doesn't matter, startups, the key point is to the manufacturer have to test in a proper way. And what means proper? Proper, there's quite well-defined testing systems. There's known testing methodologies. And interestingly, there's also several testing standards and regulations, but does your manufacturer do that? Is there someone to regulate that? Now, the big difference in quality and safety is testing. As I mentioned, there are different types of testing. We won't jump into this. Testing alone could be an entire course, or an entire academic course in a university. Yeah, it's quite a lot. But what's interesting for you to know is there are different categories like functional or performance testing, environmental testing, durability, safety, benchmarking, and then the certifications. These categories can be a mechanical, functional, or a mechanical thermal, or a mechanical electrical. So these are like a matrix. And these tests can be done either in a simulation environment, a test bed, or in the vehicle. The mode actually controls the optimization of the testing, the cost and optimization. That's what the manufacturer has to think of. But these two, the type and categories, these are required. These are essential amount of testing to be done. So with that, actually, I think it would be it's an apt point to lean into safety and hand over to Vijay, who will be able to talk about the safety and regulations. Thank you so much. Hopefully, this was an optimal level of overview, a little bit of technical info, but mostly general. Are there any questions? Actually, hopefully I've finished at the right time as well. Again, if you have any detailed questions, we can discuss offline. But for now, do you have any questions that I could help with? Maybe we can take, Danny, do we have a time for 1 or 2 questions if there are any?
Yes, sir, we can go ahead with the questions. If anybody has any questions, and if you have the right hardware, you can unmute yourself and ask the question. If not, you can drop it on the box and I will read it aloud.
Then if not, we can move on. We can also have a Q&A at the end of the session.
Yes, sir, we'll proceed with that.
Actually, I have something. Kanish, drink water. What's the question? I'm not able to read here.
He says lithium battery needs more raw materials.
Yes, I mean raw material is needed for any of the component, right? So yes, yeah, lithium. That's true. Actually, the processing of the batteries do require more water, but then there's nothing that comes free. To be honest, you know how much of water a single jeans pant uses? 11,000 liters. It's a true statement. I'm not trying to deny. I think water consumption included in the overall production process of, if you compare from the raw material from point one, what we call as the well to wheel or well to pipe, it is a lot compared to the combustion engine, but combustion engine gives a different level of issues, right? I mean, they also use water and resources, but then the chemical and the pollutions, what you have in your oil refineries, that's a whole different story. So I think we have to compare apples to apples, but that's also a true statement. Where we go. Good point. Yeah, thank you.
I think Mr. Kanish is being convinced by the answer. So I now call upon Mr. Vijay Dinakaran, Technical Regulations, Renaissance, to proceed with the second part of this webinar to discuss how safe are electric vehicles and what are the procedures that the manufacturers do to ensure safety. Sir, the stage is all yours.
Thanks a lot, Ashwin and Henry, for setting the context. Is the presentation visible? Can someone confirm it? Hello?
Vijay.
Thanks, Mani. So, next 20 minutes, we are going to talk about the rules, norms, regulations, the topics which are not good to discuss in the afternoon session, but I try to keep it very simple. We are just going to just three elements of electric vehicles, as the topic suggests. Are the EVs safe to use? Okay, so the first one we are going to see is the context. What is the situation that we are going through? And then we come across the questions, because as a customer there will be a lot of questions, the government has a lot of questions, and the industry is also having a lot of questions to be answered. Then we will see what is in store for the future. These are the three things we are going to see. So with that, I thank you everyone, because we always have topics to speculate, to manipulate and many things, and webinars like this is kind of a first point where we come together and discuss. So people who have joined or open for discussion, I take it that way, and welcome you to this webinar again. So to go to the basics, for any product, it is always the customer. The customer is the king. Yeah, we always agree with that. And if you see this picture, this is one of the vehicle that has recently got fire in southern part of India, in Ooty. And there are a lot of speculations in the Twitter. This is happening. This is because of that. And one customer, one of the Twitter member has posted that EVs always catch fire. So it was very funny, because we should do the fact check. Fact check is very important, and this is an ICE vehicle. It's a petrol turbo vehicle, and it's not an ICE. And very preliminary report. The first preliminary report that has been made within 48 hours of the incident reveals that the customer has tampered the electric wiring harness, and he has fitted an infotainment system. So that is the root cause for this fire. So then what we should look for, it's not like what we want to look, but it's what actually that's happening. So that's where I want to start the presentation. Now moving forward, why EVs are discussed, that's very important. So what is the present situation of EVs? If you see, since 2010-11, when EVs have started globally, India was very late in the race of EVs. We have jumped from 4,000 two-wheeler sales last year June to 42,000 two-wheeler sales this year, and three-wheelers is like where the biggest breakthrough has happened in May 2022, where the ICE three-wheeler sales dipped and the EV three-wheeler sales has crossed the sales of the ICE three-wheeler. So it's a very positive thing. So a lot of consumer awareness, everything has started, and all this has happened in the last financial year. And what happened in parallel? We need to, as I told, fact check, and we need to be very transparent on what's happening. So we had many incidents, fire incidents, and just we will leave the company names because that's not the here, but and NMC battery, LFP batteries, but all those things are there. But the bottom line is safety is the top priority. There should be absolutely no compromise on that. That is the thing. So the financial year 2022 is a mixed bag for EVs. Okay. Now, coming to the global situation, let's take a step back and see why EVs are discussed, whether EVs are very new, it's been invented in 20th century, why it is discussed suddenly. So we are going into a very, very complex situation. So because of industrialization, everyone in the, like in a family, once they get a job, they want to buy a two-wheeler, four-wheeler. It's the aspiration. So individuals have their own aspirations and all those uh, 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 individual objectives, which translate into more and more sales of two-wheeler, three-wheeler, four-wheeler. And also, not only that, the consumer market is increasing. Electronics has been disruptive last 10 years, the way we use the mobile phones, earpods, and so on. So, so, so the target which has been fixed in 2015, COP26, they call, is 45% reduction in emission, and we need to maintain that the average temperature rise should not be more than 1.5 degrees. So how they arrived at this number? So there was a very big intergovernmental panel on climate change. They call IPCC. So you can check IPCC website. There will be lots of work groups. There are 6 work groups, and they have different agendas to study. And each work groups have studied this for 5 to 7 years. Few work groups has gone a decade, and they arrived at this number as it is good for the earth and the people who are in the earth if the average temperature shall not exceed by 1.5 degree. And they also made a last COP meeting in UK where they presented that what happens if the temperature goes beyond 1.5. So one is the melting of Arctic Circle, which we have like in Antarctica and other things we see, and the other one is the drought, and so on and so forth. So if, for example, 3-degree increase, we expect drought condition to be 6 months per year, which is like half a month, like half a year. That's what the projection looks at it. So it's very glaring and alarming, as Henry has told. So what the next step at the globe level, and then comes to the continent and the country level. So people started talking about net zero, like now the people first started talking about the carbon neutral. Now they are talking about net zero. Then there will be negative carbon, so that we need to go much more below. And India has announced a target for 2070. Even though that is the net zero target, we have other targets of going to renewables and going towards cutting down of emissions. All those targets are falling by 2030. So on the right side, I kept a very interesting graph to show you that when EVs have actually started. So you can see like 1899 is the one of the very first EVs have started. We had EV charging station in 1898, which today we are talking about charging station is not there in India, but there were charging stations which were in 1898. And we had very good EVs which are going to 100 to 150 miles between 18th century end and 19th century beginning. So EVs are not the concept which has been born in 20th century. It's there, but we are now adopting because there is a context and there is a background for it. Now, so when we are adopting a technology, so we will quickly check the what is their strength, weakness, opportunity, and threats. So one very clear strength we can put forth for EVs is it's less polluting. We cannot say any mode of transportation except you're walking as a clean technology or eco-friendly technology, but it is less polluting. That's very clear. We have made a study recently for an entry-level car. Maybe I can take an example of an Alto or that level of a car. So a regular car produces 90 to 105 grams per kilometer of CO2. This is the CO2. And when it comes to EV, though there is no emissions, there is no tailpipe emission in a pure EV vehicle. But still, as Henry has pointed, it is the well to wheel, all those things aspect, right from the minerals to the tires fitted EVs on the road. If we take all those factors and then we make the calculation of CO2, what has been emitted, still it falls at 40 to 50 grams, which is 50% of the ICE. So that is a clear strength of EVs. So EVs, there may be many speculation that the electricity is coming from coal, then EVs are not clean, all those aspects. But if you check the Central Electricity Authority of India, uh, the outlook and the reports, which is like quarterly reports for the last 5 years, since 2017 onwards, you can see a clear trend that we moved from 50 gigawatt of renewables to 175 gigawatt, which is like by 2022, and we are targeting 500 gigawatt by 2030. By then, by 2030, our demand will be around 850 gigawatt hour. So 500 gigawatt, which is out of 830, is roughly more than 60%. So that it cannot happen like it's the chicken and egg story. Always they say EV comes first or the charging infrastructure. It applies for everything. It cannot. The ecosystem grows together. It cannot happen one complete growth and then the other will follow. It cannot be sequential. That cannot happen. So then the crude dependency. This point is covered by Henry. We are a highly import dependent country, around 80 to 85%. Out of the two-third goes into the two-wheelers, all those aspects, and less moving parts. Again, it is covered. Coming to weakness, so many strength. Then what's the weakness in EV? So today we see inherent weakness of range anxiety because of the battery price and the weight, and then the image of EV. If you see any vehicles that have been sold, the trend is now changing. We have very good looking two-wheelers launched in India, very safe two-wheelers, very safe four-wheelers getting launched. The image is getting changed, but still people feel EV is a city vehicle or it is like a kind of a concept vehicle. It cannot be commercialized, all those aspects. And opportunities, as I told, it can be a zero emission vehicles. When I say zero emission, of course, factoring those CO2s during the production that comes, but when it runs on the road, it is a zero emission vehicles. And two-wheeler has already started to lead the market. Three-wheelers has also crossed like the ICE sales. Four-wheelers is work in transition. So all these segments will go hand in hand. And then there is a very interesting thing that we can do with an electric vehicle is V2X. It's vehicle to load or vehicle to home, vehicle to grid, anything you can do. So you can take the charge from your batteries when there is a kind of an inverter application when there is no power at your home. So those are the opportunities there, and many more things can come up when electric vehicles come into a mainstream production. Now coming to threats, we have today what we see is the compromise on the quality and safety because of the cost competency, customer apprehensions to be answered, and the durability issue, like how long the battery will be there, and when the battery should be replaced. Okay, so now what are all the challenges? Now, if there are a lot of technologies available for carbon neutral or net zero. So we like as a globe, most of the trend is going towards electrifying very clearly today because of the cost competency of electric vehicles compared to the hydrogen fuel cycles. Like hydrogen fuel cell vehicles today, the green hydrogen production cost is somewhere around $6, which is like December 2021 price. So $6 per kg on the production cost. Then you can consider what will be the price when it comes to, let's assume $10. Then it will be like very similar to the situation. 1 kg of hydrogen will be around 800 rupees. And again, you can go around somewhere around 75 to 90 kilometers is the present day cars that has been like very few cars today available. So then you can again calculate all those simple max. So today EVs are the only front runners today that is available, but there are a lot of challenges we need to answer. So first and foremost thing, so I had recently conducted a very interesting survey with a B school students, around a sample of 50 students, and I have got answer that charging infrastructure comes to their mind, which is more than 50% when they think about EVs, and that is the main concern which they feel they don't like to go for EVs. So it has been echoed by Deloitte and other many consulting groups also. Like they also say that Indian customers are worried about the charging infrastructure. And the second most important point is how safe are the EVs. That we will see in the next couple of slides. And someone has asked the question. So that is the main headache for the government where lithium comes from. So So even though, just to give a number, the amount of lithium used by traction battery is very minimum, which is not even 5% by weight. But still, lithium is not only the element, we also had nickel, manganese, cobalt, and all the elements that goes into a battery or something that we need to import. So what's the alternative? It can be the substitute for it. So those are all the challenges today we have. Okay, now we go into the regulations. I kept it very simple. This is the regulation. The number of tests today India, Europe does for electric vehicles. So we put the batteries in the four-post and then do a vibration test. We crash the electric vehicles at 56 kmph against a deformable barrier and then check whether the electrolyte leaks, there should not be any fire or smoke. And then we externally short circuit the terminals and then check there should not be fire or smoke. And we keep it completely on the charge, similar to what we do with the mobile phones today in the home. We just put it and we forget it. So if we are doing it to a battery, which is like maybe 2 kilowatt or even a 70 kilowatt, so what happens? So that is being performed. Plus, there is a nail penetration test, like you puncture, because our roads, not only our roads, like any roads in the globe, of course, there might be a chance that there will be something on the road that can puncture into the vehicle. So these are the 5 tests today, which have been done by the Indian government, by the test agencies, to check whether the batteries are okay. Now, it looks everything is covered, but as you know, we need to evolve with the market situation and things like that. Something has come up as GTR 20, Global Technical Regulations, which has been recognized by around 190 countries in the globe. So India is also party to it. So this regulation was published in March 2018, and once that is published, the countries should take the requirements and then they need to make their own standards. And then they need to give a lead time, because the test and validations are at the end, but for that there should be a design and development should happen. So it came in 2018 and then it is adopted in different countries in different timelines. So any vehicle that has been sold in this particular country, for example, China is the first country to adopt in January 2022. Any vehicle to be sold in this country, they need to meet this requirement. And then we had US, we had Korea, and Europe and Japan is going by 2025. So anyone can guess when India is going for this particular regulation. You can see the global market. So these are the 4 uh, big markets where not only by volume but the amount of regulation they impose for the quality of the sold. So any guesses when India might be going for this regulation? Even you can put in the chat box. There is like absolutely no issue. It's like it's just a random guess, because we always see that India will be going by this timeline or anything. Any guesses? Okay, Gokul says 2030. Okay, so let's see. India will be the 3rd country after China and US, and India will be implementing it from December 2022 in 5 months. So this is one of the, I think this is the first time in the last 10 years or so that we have gone very aggressive and we have gone for a regulation which is much ahead of Europe or Japan. So always, like, India follows European Union regulations by and large, not 100%, but they follow the technical requirements from Europe. They carry it and then we adapt it for the because our ambient condition, everything is different. So we used to adapt the regulations little bit, tweak it, and then we implement. So in this case, we are at least 3 years ahead of European Union and Japan, and we are almost close to US and China, and we are ahead of Korea also. So now we will see what is getting added because of GTR 20. Okay, so we have seen mechanical, electrical, now thermal is getting added, and then we have few more tests getting added in the mechanical and electrical. So we had external short circuit, overcharge, now we have over discharge and over current protection. We had vibration and mechanical shock, now we had mechanical integrity and vehicle level test as an optional. Like, you can do at the battery level or you can do it at the vehicle level. And then thermal, they put it the battery on a vessel and then they fire it. and then you make a thermal shock link. Like this is thermal shock is very common in India because outside it may be 40 degrees. We enter into a cabin where it can be 22 degrees. So this cyclic has been done, and then over temperature because everyone don't park in a closed parking. So considering all this, plus adding all these requirements, plus there are two important documentation items which has been added because today even the global experts are finding it difficult to make a test procedure. So today it is documentation. One is what Henry has mentioned, which is very important, the thermal uh, propagation. So what is expectation from the manufacturer is 5 minutes before any fire is going to happen, there should be a telltale indicator, optical as well as audio warning, which should come on the vehicle so that the occupants have sufficiently time to get out of the vehicle. And within that 5 minutes before the event is going to happen, prior to the event, there should not be any smoke entering into the cabin of the cars because the occupants tend to get giddiness and things like that. So that is one, which is thermal propagation. And the second one is low temperature test, that the manufacturer should declare what is the lowest temperature the battery can work. And for example, if the battery can work only until -15, if the temperature goes below -15, there should be a mechanism in the vehicle that it brings it back to the normal operating temperature. Okay, so that's on GTR 20. We had this is for the cars specifically, and for the two-wheelers, they were different standard, but by and large, it is almost the same requirements. Thermal propagation is being there in a different form, but the requirements are by and large the same. So both for four-wheelers and the two-wheelers, any EVs which will be sold in the country from December 22 should meet this requirements. Okay. So with that, we go into the incentive part of it because regulations are regulations that are laid to be met. And one more information is that for any regulations, for all these tests, whether it will be tested only once and then the production will not be monitored. No, it is monitored once in 2 years. Every 2 years, the test will be repeated by selecting a random sample from the production lot by the government test agency. So that is also different compared to European Union, because European Union, it's not a government test agency, it's by a third-party test agency. So in that way, India is more stringent. And after the recent fire incidents, it has been considered what can be more stringent, because we have gone to a level which is at par with the global regulations, and so also the timeline is very stringent. So after this incident, the government is also considering all those issues are very serious, and they want to have, if there is any opportunity, to have more test, more regulation intervention on this topic. Now coming to the incentives, so FAME, the faster adoption and manufacturing of electric vehicles. When I say electric, it is electric including hybrids here, and which is like strong hybrid or the plug-in hybrid, the way it is called. So faster adoption and manufacturing of electric vehicles too. And the scheme was announced in 2019 March, and in the last 3 years, the target was to incentivize 86 billion INR and to have 1.56 million vehicles on the road. So you can see the split, how many two-wheelers, how many three-wheelers. But unfortunately, because of the various reasons, one of the main reason is very strong localization criteria. FAME demands almost all the EV components to be manufactured and assembled in India, which will be very difficult because the volume is very low. So the economics of scale is being impacted. So very limited OEMs today gets FAME incentive. And there are other criteria, like if it is a car, anything that is priced above 15 lakhs, you will not get the incentive. So that is also one of the criteria because of which many EVs today even sold in India, but they don't get FAME incentive. But we can see many on the other front, we have Tata Nexon and Ather Energy and so many vehicles which do get FAME incentive. So today's situation is 23% of the incentive amount has been consumed, and 31% of the target has been achieved, mainly because of the two-wheeler sales in India. So by 2024, the scheme will end by March 31st, 2023, next year. sorry, it will end by March 31st, 2024. So when it ends, then we will come across what will be the budget that is being consumed on the vehicles that is being sold. Okay, now the previous incentives is from the central government, and you can see very clearly when the FAME was introduced, there are very limited states which were giving incentives from the state side, like Maharashtra and Karnataka are the only states which were giving incentives. But on the right, you can see there is a big change in the trend. Even still, you see many states are not very much concerned about it, but there is a big change. For example, 8 states have implemented the EV policy. So when you say implemented, that means it is the final notification given by the government. When I say final policy, the policy is final, but it has not been implemented. That means you will not get the incentive. Draft policy is something work in progress. Media announcement is whatever comes on the newspaper. So you can see a very clear trend along with the FAME. The states also found the necessity that they want to also contribute to the commitment of the central government to the COP26 agreement, all those things. And the states also want to attract EV as a new technology in terms of investment, in terms of consumers, everything. And that's why this trend is being seen. And recently, Delhi government has announced that they are going to give 15,000, 10,000 to 15,000 as an incentive for electric cycles, first 1,000 electric vehicles to be sold. Okay, now what is the government direction? It's just a prediction. It's purely what I have studied, looking at what's happening in China, Europe, and US. So everywhere it started with incentive. So FAME will end by March 2024. After that, what happens? Today we don't have any document to say what happens after FAME 2. So it started with FAME, PLI scheme, which is production linked incentive, and then we have GST. Just typically, if I say, except the cess part of it, cars and two-wheelers, any automobile is priced at 28% GST, whereas electric vehicles is at 5%. Top of that, cars will have 28% plus 15% or 22% based on the length of the car, based on the ground clearance and the engine capacity. So it goes as high as 50% as a GST, but whereas you pay only 5% GST for the electric car. And then these are all on the incentive parts. And the second one, there will be on the regulatory push. So how regulation can push electric vehicles adoption? You can see there is a regulation called KEFC or CAFE. In India, we called KEFC, corporate average fuel consumption, which means a manufacturer has 4 models and each model is sold 100 volumes, so 400. So the weighted average and the CO2 of those vehicles, so he can have a target for its fleet based on the weighted average. The average weight, maybe it comes around 1000 kg as a average weight of the fleet for 400 vehicles. Then there is a regulation which says how much CO2 as a fleet, as a company, they can emit. If they go beyond that, of course, there is a penalty. So what they need to do, if they have a small vehicle or a big SUV, they should have a equivalent amount of electric vehicles also, so that the CO2 will be much lesser. And also, as per KEFC regulation, 1 electric vehicle sold will be considered as 3 sold. So that means your number will increase and the corresponding CO2 also will be very less. So that will be there. Today we are into stage 2 of CAFE. Stage 1 started in 2017. Targets to start with is it's not so stringent. By the 2022 targets, which have started from 1st April this year, is very stringent. We expect the stage 3 should be coming somewhere by 27-28 time frame or by 2030. That is expected to be very stringent. So that means the inclination is going towards something moving out of petrol and diesel vehicles. And what happens after that? Obviously, the route is like first give incentive, then say it in a very polite way, and then it goes as a ban and mandate. So that's how it is happening in like it has been announcement. There have been resolutions passed in many countries, so that can happen. Okay, so this is on the prediction. Now we need to focus what is expectation on the customer. So this is a very like important aspect I want to put, because customer has a lot of expectation on the vehicle. The vehicle should have good range. There should be charging infrastructure every 1 kilometer, so that they can buy and they can not, like they can be sure that there will be enough charging stations and things. But there are very important things. expectation on the customers, because we are moving from one technology to another technology, which is completely different. As Henry told, the moving parts is different, the way of operation is different, and many aspects. And the amount of current and voltage and the power we are talking is completely different. So we should have a very basic knowledge, because we all have that habit that when the sales executive explain the uh, details of the product, you will be sitting in the new car or the new two-wheeler and checking the color and scratches and things like that. We never used to give attention to it, but that is where the change should happen. We should have a very basic knowledge of EV, and we should have an understanding of the vehicle what we use. That is the wiring harness, what should be touched, what should not be touched, that is the battery, how to use it, whether we can touch it, all those things. Because many of the EV incidents happened in the last 6 months or so. It's not only because of the product defect, but it also about like you remove the battery, put the charge, like similar to what you do to the mobile phone. So we need to understand what we are dealing with. We are dealing with kilowatt of power, and as Henry told, we have very basic EVs comes with 240 volt systems, 240, 300 volts electric cars, and it can go as high as 700. And there is technology, but technology and infrastructure cannot make the end objective successful. It's about the awareness of the product. So, and at the end of the day, it's about common sense. So that's why I kept it at the bottom. It's about very basic common sense what we have on the products. Okay, so this is the survey which has been conducted 2 days back by with myself with some of the students, and what we see is that around 38-40% of the survey they say that consumer awareness is the aspect which is to be focused in India. Incentive, yes, to start with, incentives are important, but it cannot be sustained at the long run. And then we have safer products, because that is after this incident, that is also one concern. And then equally important is India centric products, because the products should be tested in the Indian market for the Indian regulation, and that is also, and there are a lot of other aspects also, but the major focus to be on the consumer awareness part. So with that, I leave the floor to Mr. Manikandan. With this, one last message from my side is that there will be always manipulations and will be a lot of apprehensions when a new technology comes. So if you see, this is a very important image which I picked and I always like. Is a cartoon that has come up in newspaper when they went mainstream electricity transmission. So people were saying electricity over the head, it is going, people going to die, everything is going to be end of the world. But today we cannot imagine a world without electricity. That becomes our part of life. And then so it's the same, it's about the consumer and the products who will decide the future. So it's not about customer is the king, but customer with the right minister's eyes, ears, and mouth will be the king. So that's my message. Hope it is interesting. I am very happy to take any questions. I will wait for it. Hope I completed on time. With this, without any delay, I leave the floor to Mr. Manikandan. Thank you.
Thank you, Mr. Vijay. For the last presentation of the evening, I now must call upon Mr. Manikandan, Managing Director of Spero Mobility and Energy Solutions, to discuss on the safety aspects of electric vehicles from a consumer's perspective. Sir, the spotlight is all yours.
Thanks, Danny. Am I audible now?
Yes, sir.
Is my
Yes, sir.
screen
You can
visible?
proceed.
Okay. Henry and Vijay, thanks a lot. Thanks for making my job very easy. As my friends have been saying, the new technology, a lot of adaptation questions, the consumer mindset's changing. We've been talking quite a bit. I'm sure Vijay did put it across in one of his slides that electric mobility is actually not new. It actually is not new. While I say that, Why do we actually say that? Not just new, it came before internal combustion engines. From horses and steams, we moved to electric mobility before we said that there's an opportunity to move into internal combustion engines. So electric vehicles were actually between steam and fossil fuel. But over a period of time, the vehicles were phased out because it was much more easier to handle fossil fuel, and Ford managed to produce cars at a much more cheaper price than most other manufacturers, went into a mass manufacture. If you see the whole shift from electric mobility to fossil fuel, one side fossil fuel is available in abundance, two, the cost of automobiles actually changed tremendously. Is the new generation electric vehicles post a Tesla? No. Goes back to 1996. This is from General Motors. One of the world's largest automobile companies started making electric vehicles as early as 1996. They did not use lead acid batteries like the predecessors. They used lithium batteries. A lot of vehicles were tested. They were not sold, but they were given to people, dignitaries, others in California in particular. They had a fantastic run. Ultimately, at one point of time, the consumers decided that electric mobility is here for good. But General Motors as a company had different ideas. They decided to withdraw all the vehicles and they were destroyed. Almost all the cars were destroyed, but for a few which are lying in museums. Now, why did this happen is still a mystery. Quite a lot of people have debated over that. Do we still say that, electric vehicles in 1996 were too adventurous at that point of time? The mystery still continues. But post Tesla coming up and saying that this is how automobiles had to be made, the difference was there. Now, let me run quickly. I know I'm overlapping into Henry's discussion, but what I actually wanted to stress upon here is the last two aspects. From a mechanically controlled system, we are more into electronically controlled. Cars have become more intelligent and connected. These are two things that I actually wanted to portray: intelligence and connected. The world has changed tremendously from its telecom revolution. Gone are the days, when you had a cap on the number of characters that you could text, type and text. Then it slowly started evolving into the sizes went up. You could send small images, and now you're actually transmitting videos. With the kind of reception that's there for 5G telecom in India by the Adanis or by Jio or by Vodafone or Airtel, it's actually going to play a very, very pivotal role in next generation electric mobility. Or let me rephrase, or let me correct myself, next generation mobility. Now, if you look at this, you will not see that there is a major difference between what happened in the past, where the batteries were stored, and where it is actually being stored in the current generation cars. 1898, the batteries were stacked on the chassis. Today also, Tesla starts to stack their batteries there. Not much of DNA has changed there, but what's changed is beyond that. In terms of communication, in terms of keeping it well connected, in terms of giving you a different safety parameters, all that is what has changed. Now, let me quickly come back to what exactly is my agenda for the day. These two I have portrayed as India's entry into electric vehicles from a very large difference. The top one is the Yo-Yo scooters, and the bottom one is actually the Reva from Maini Motors. They happen very, very quickly. My colleague Vijay was talking about very strong parameters being set for FAME 2 disbursement of subsidies. So when yo-yo came in, left, center, right subsidies were given. Once the subsidies started to get stringent, yo-yo sales actually stopped. That means the sale of yo-yos was prompted by the incentives and not by actual acceptance in the market, because the vehicles were failing. The technology was different. They were using different batteries compared to what we're using today. But let me draw back to what exactly happened with Reva. The consumer mindset in India was actually evolving. We were no more willing to take the Hindustan ambassadors and the Premier Padmanis. We actually want beyond that. Now, with that sort of a mindset, the Revas actually could not scale beyond a few being sold in Bangalore, rest of Karnataka, some of them in Tamil Nadu, maybe a few in Maharashtra. Of course, they did have a reception all the way into the United Kingdom. They have sold a few in the United Kingdom. Things didn't take off. Maini Motors could not grapple onto the opportunity. They had to give way to Mahindras to see how their technology, their know-how could be taken on to the next stage. Now, let me come to the actual crux. Where are we today and where would be in the future? How is the consumer actually perceiving this electric vehicle adoption? Government policies are one, thanks to Vijay, who said, initially it's going to be incentivization and then there's going to be bans and others. Categorically clear, because Government of India has a mandate of carbon neutral by 2070. In the last 5 to 7 years, Indian government is known to actually beat its targets that they commit to the global world. That means I'm thinking that the 2070 carbon neutral story that we are trying to put as a milestone may actually be, if not 2050, but at least the 2060s. Meaning we do not have much options left but to take up the bandwagon of alternate fuel based mobility, which for all practical purposes may be an electric mobility or maybe a hydrogen based mobility. Let me get into how the consumer is perceiving things. Product innovation is a key factor that the consumer today feels they are not ready to give a compromise on. They don't want the ambassadors and the Premier Padmanis or the 118 NEs or even a Maruti 800, the base design that came in the past. They're looking at something beyond that. Then the second aspect is the safety, which Vijay has dealt in detail. I'll dwell into the other aspect, which is the cost concerns. There's not much that needs to be spoken about in terms of connected mobility, because technology is just evolving. We hardly have a few vehicles, but I will put it across in a few pointers as I go forward. The rest of them, autonomous mobility, increased charging stations, swap stations, how the government evolves as policies, we will see as we go on. And when you look at product innovation, India has always seen you make a matter of fact vehicle or you make a matter of fact product in the past. But things have evolved beyond the 1990s and the early 2000s. Things have changed. Our electric mobility story started with imports from China, be it the two-wheelers or the three-wheelers. Very evident from the initial few scooters that came in different colors, chassis. They were not the Indian mindset accepted products, but those were what was available. Within that, probably the common man was picking and choosing what he or she wanted. Then comes the three-wheelers that we are used to seeing in the past. The garbage trucks, the slow-moving autos that you see on electric mobility, they don't have a great chicness around them. So the consumer is still not happy about moving into that product. But for a matter of fact, if it is application driven, it is acceptable. That is where the traction has actually been. And they've been pure EVs. So as a community, we always look at a resale value for a product that we own. What do I do with the existing vehicle that I have? If I do not have a resale value for that, my fear is that if electric mobility runs over, snowballs, then my existing ICE vehicles will probably have a lower resale value. Or what do I do with the existing product? It's a chicken and egg game, and people are yet to make up a decision on that. Then the other aspect is, because the costs have to be kept low. The original trend was lead acid, and then now it's lithium batteries. So I give you a slightly lower mileage, and I stack the battery as in where I'm able to find an opportunity. And these were largely driven by third-party players, not by the automobile majors. Be it two-wheelers, be it four-wheelers or three-wheelers, the existing auto majors in India, the Tatas, the Mahindras, the Eichers of Royal Enfield, story, they all are taking a wait and watch game. The reason was all of them had invested heavily in Bharat Stage 4 and Stage 6. It meant they had already invested in a lot of money to make better engines which will pollute lesser. So they had already put the money in, and they were not sure if they had the wherewithal to invest in this also and run a parallel business, but they decided to wait and see how things happen. This was encashed by the startups like what happened in the global community. Electric vehicle industry in the world is today powered by startups. Now that's why I use the word emerge or emerged. Some of the startups have already become established players. If you look at India, I'm talking about an Ather, I'm talking probably about a lot of companies which started with third party funding and then have established themselves and have put in a very, very strong commanding position and will be a serious threat to the existing players like a TVS or a Bajaj when they come with their own bandwagon of electric vehicles. The startups actually had no frills attached to them. So they started working on next generation designs. The Ather scooters were unthought of in India. Nobody would have thought of that kind of a slender design. Just imagine the kind of time that they spent on the stand that they have. There's a space for the stand to go and park itself. Those are the kind of things which a startup would imagine, but you wouldn't imagine that coming in from a larger automobile major at that point of time because they never felt the need for it. If the vehicle is good, it's good enough. We stop there. But startups actually wanted to make a big difference. This is how they started to make the difference. And I was just talking about the 5G auction trend, which is picking up, which means connected vehicles are here. Your cluster is actually going to be connected. You would know where you're headed. Somebody down at home would know where you're coming to without even having to do anything of that sort. So with all that happening, there is a lot of room for product innovation to happen, be it startups or startup becoming established players or the existing automobile majors. There is an opportunity in the making. Now, this is a classic. I'm visualizing one of India's oldest corporates, the Tata Motors, willing to think like a startup. 25 years back, nobody would have thought that the Tatas would visualize something like this. I don't even want to draw a parallel to their acquisition of JLR. This, I think, transcends beyond that. Imagine a company like Tata Motors willing to think like a startup. This is fantastic. You can imagine if this is happening, it's because they are listening to the consumers. Product innovation is the way forward. If you do not innovate the product, make it beyond globally acceptable standards, you will not find consumers to support you. Now, that listening factor makes a big difference. I think all the automobile majors and the startups are listening to consumers and are taking product innovation to the next stage. The second aspect from a consumer perspective is actually cost concerns. The premium that you have to pay to own an electric vehicle compared to an internal combustion engine, which is very, very critical to understand. Henry rightly pointed out 25% cost actually comes from batteries. Though the engine is not there, the motor is inexpensive compared to the engine, 200 parts versus 2000 parts, but still a good electric vehicle is more expensive than the internal combustion engine because the battery costs are extremely higher comparatively at the moment. If you look at the impact of FAME 2, personal income tax benefits, thanks to Vijay, you're aware of the fact that the norms are very stringent, so it's not having actually an impact on almost all the products that are being sold in the country. If you look at the break even, which every Indian actually looks at before they acquire a vehicle, 15,000 kilometers to 1 lakh kilometers if you have to draw a parallel between internal combustion engine and electric vehicles. Now, in today's rapid changeover field, I'm not sure if I will hold a vehicle for 1 lakh kilometers. used to do that in the past. I remember when I had a Mahindra Scorpio, I think I sold it after it crossed the 5 lakh mark. But today, I don't think I will let it touch that 6-figure mark before I want to move on to another vehicle. Resale values of EVs are still not well established, because the moment we say EVs, the first question that everybody props up is that what is the cost of replacing the battery? As a manufacturer, we say that, I give you a 3-year warranty, during which time I replace your batteries. Tata Motors on their Nexon gives an 8-year warranty for their for their batteries. But before I buy a Nexon, the first question that comes in my mind is, what if the battery fails? We look at the cost of replacing the battery the moment the warranty period is completed. And because Nexon says it's an 8-year or a 1,60,000 kilometer, the decision is tilted towards a Nexon. A marketing thought process coming in the way of Tata Motors having decided that very, very immaculately. Not just that, FAME 2 mandates an 8-year warranty on the batteries. So they have taken FAME 2 also, but also taken the consumer mindset and decided on it. Another interesting factor that's happening is that to alleviate your fear on the battery and the replacement cost, Government of India has accepted to turn battery as a service. So it can be a lease, or it probably is a swap system depending on the manufacturer. And the next important aspect on the cost actually is the story that's coming in now. Home charging versus third-party charging. When I say third-party charging, I'm talking about charging stations which are available, or swap stations which are available for you to charge away from your home. I'm running out of time, so I'm passing this on. The next important aspect is range anxiety. It's a very, very serious threat. Now, when you buy an internal combustion engine-based vehicle, we say that we are not worried about range at all today, because in the last 20-25 years, the oil majors have opened up fuel stations left, center, right. Even in a rural area, at least every 20 to 30 kilometers, you will see a fuel station. Between an Indian Oil, Bharat Petroleum, Hindustan Petroleum, Nayara, whatnot, or a Geo for that matter, you will have a fuel station somewhere or the other. It's interesting to just read out this. I'll just take a few seconds to read out this. John D. Rockefeller's part of Standard Oil says, the best business in the world is a well-run oil company. The second best business in the world is a badly run oil company. Now, that was what was thought of by the world's leading business houses which were involved in fossil fuel. So everything around the world's economy was around fossil fuel or automobiles. This meant rampant growth of fuel stations, alleviating your range anxiety. But when it comes to electric mobility, we've got a problem. It's not just a simple chicken and egg story. It's actually beyond that. It's taken almost 40 to 50 years, or maybe, independent India, 75 years to actually have this kind of a fuel station, population or density. Why is it that we can't be a little more patient to have the same sort of range anxiety alleviation in electric mobility? Home charging options, third-party charging options, swap stations. I don't know how many of you know about this company. It's an Israeli startup which went bankrupt in 2011. It had the capability or the technology to actually swap automobile batteries left in totality, completely robotically controlled. They came well ahead of a total swap, because the battery of a car is not going to be 12 kilos or 15 kilos like what we see, like what is this done in Gogoro, a Taiwanese company. It actually is probably about 250 or 300 kilos, in some cases even more heavier than that. So you definitely will not be able to do it yourself. You'll need the help of an external organization or a contrivance. Better Place went bankrupt in 2011, but Tesla is now talking about automatic changeover of batteries in due course of time as the next biggest opportunity for them as an organization. Now, I will come into a very interesting aspect which I've been debating with my colleagues in the community. This is the cost involved in home charging. A 2 kilowatt, meaning for a common man parlance, it's about 2 units of electricity. Anything between 2.5 to 5 rupees is probably your cost. Even if you're paying 5 rupees a unit at prime at your domestic power tariff, for 2 units you're probably paying 10 rupees a unit. Look at what I have at the bottom. If you're looking at a third-party charging station, the cost is anything between 19 rupees to 25 rupees. Some organizations charge a parking fee, others don't. So just imagine you're actually paying 4 times the cost involved in domestic charging versus third-party charging. You're looking at probably the same tariff that you pay, or probably slightly higher tariff that they probably would be paying, though the government of India has got a unique tariff system for electric vehicle charging. So this is actually not helping the common consumer make up his or her mind to move to EVs. A lot of planning has to happen on home charging, then look at third-party charging. So a lot of government influence is required on this to rationalize charging rates or to bring in a tariff. Government of Delhi is talking about it, and I presume as we go along in the next 18 to 24 months, countrywide, there probably will be a policy on what should be the cost that you charge on a per unit basis, so that this range anxiety is not just alleviated, but the cost advantage also comes in with vis-a-vis home charging. I'm not saying you have to compete with home charging rates, but I presume a 30% or a 40% premium is okay, but a 400% is actually abnormally high, which is pulling down the way the industry can actually grow leaps and bounds. Safety has been dealt quite a bit by Vijay. I'm running out of that. I'm passing on. Renewables powered EVs is the way the future is actually looking at. EVs, batteries to be a storage is what the future is talking about. The energy surge for 2030 to 2050 is a matter of concern which everybody should be looking at. Again, the 2070 targets very, very critical. Henry took a call on case, so I'm actually passing on that also. So this is where the actual topic ends, but I would like to run through a few slides to tell you how exactly the future is actually driving towards. What is the industry looking at the trends that the industries are actually having towards 2030 or 2050, whatnot. We spoke about energy consumption. If you look at an electric car, it's slightly more than a bus. Forget the scooter, forget the cycle, just look at the electric car. Slightly more than a bus, or probably 40% more than a bus, which means we are here. Electric mobility is definitely going to be marching forward, because you save power, you also are less pollutant. And mind you, this is per person. It's not the entire bus being calculated. Look at the, again, carbon emission, which becomes very, very critical at today's aspect. It's still very, very comfortable compared to what exactly, an ICE versus electric car topic when you come. It's evolving. With this kind of an orientation, electric mobility is definitely the way forward to actually not just look at the 2070 targets, but also to ensure that we've got a better planet to actually pass on to the next generation. Henry mentioned this, but eventually, as Vijay said, 500 gigawatt hour out of 850 gigawatt hour will go renewables. So definitely we will be there in due course of time. But as we speak today, you can actually control emissions in a power plant. You can't control emissions at the tailpipe of 1 million cars. Now that means it's a necessary step forward, and it's a known devil, so we can actually manage it. This is the way things are moving forward. Corporates are moving, apartment communities are moving. So charging stations are being run with renewable power. You will see a lot of these things happening in the future. Almost all smart city projects are taking up this in a very, very big way. There was a mention about batteries to be used as stabilizers for the grids on renewables. It's falling in place. Nissan's got an amazing plan on this. I had a detailed discussion on this a few years back along with the old Nissan team. it was fascinating the way things are moving in terms of how renewables and electric mobility are being put together as a balance. And the last thing that I want to actually tell you is that the next generation driving license actually will be something like this. Without a clear-cut thought process on the way how an electric vehicle is going to be, you will not be able to sustain driving to the next stage. You will not be mobile. The comfort of today's mobility you will not have. So with this, I'll rest and my case stays rested. Thanks, Danny.
Thank you, Mr. Manikandan. Dear participants, the floor is now open for your interaction. You can ask your questions and doubts to the industry experts.
I seem to have missed a lot of questions in the chat.
Since there are no more questions to answer, I think we will. Today's session comes to a close. On behalf of Siki, I thank the presenters for making an intensively informative webinar today. The first session by Mr. Henry provided us a brief framework of what are EVs, from what are EVs to a greener environment than internal combustion engine vehicles. The second session by Mr. Vijay provided us the insights and perspectives of how OEMs and government bodies consider the EV space, which is ever growing. And the final session by Mr. Manikandan provided us on where to reflect when we consider an EV. I once again thank the participants for making this event a success, and I'm looking forward to meeting all of you in the upcoming sessions of EVOKE. Thank you. Thank you all.
Thanks, Ashwin. Thank you all. Thanks, Henry. Thanks.
Sure. Also, thanks to Siki for organizing this.
Yeah.
Thank you.
Yeah.
Bye-bye. Have a nice evening, everyone. Bye.
Nice evening. Bye-bye.